Hello everyone, can you hear me? And I think we can start our second lessons of today's, and it is about the demonstrate of the. It is a demonstrate. Wait a moment, I need to change my microphone. Wait a moment. Okay, now we will do the demonstrate about the SD-WAN experiment. And further now, let's look at what is the topology of the experiment. We will use this experiment to do the wide area internet deployment. It is the SD-WAN technologies, and we'll use this topologies, and actually it is this. You will find that we'll use 3 routers, and the 3 routers, its name is the AR1, AR2, and the AR3. And I think you should remember that the AR3 is the egress routers of the fabric network, just like we mentioned it in the WAN campus deployment. So all the configurations we finish it, we will keep it in this experiment, but we will use the controller to management the AR router 3 and configure all the configurations that we configured in previous WAN campus deployment. And besides that, we will use the controller to manage the AR1 and AR2, and we will build a virtual network between the 3 routers. And we find that between the 3 routers, we have 2 types of links. The first link, we call it the internet. Of course, it is the link. We use a switch to simulate the internet. And all the AR routers connect the gigabit 009 interface to the switches, and all the 3 interfaces of the AR routers, they belong to the same subnet, and they can communication to each other. And they use this interface to simulate the internet connections. And besides that, we will use another network to simulate the MPLS network. Of course, just to simulate, so you don't need to configure the MPLS protocols on this domain. I mean, just to configure these domains and let all the interfaces that are connected to the ARs can communication with each other. So you just need to configure the interconnect interface, its IP address, and configure the IGP protocols of those areas. So what will be next? The next is we have the virtual network between the 3 AR routers, and then we will try to communication by the virtual networks, and of course we will try to steer different application to different links, and then we will try to make the link fail, and we will see if the controller can steer the traffic to another link. That is what we do in this experiment. And first of this experiment, we need to do some pre-config. For example, so we see that for these routers, for these switches, AR switches, it should be function as the switches that offer the connectivities for the 3 AR routers. So when you configure the VLAN and assign the interface connected to the AR routers to the interconnection VLANs, all right. So we use the VLAN 615, and we configure all the interface that are connected to the ARs to this VLANs, so we can check the command on the AR switches. And I have already finished this deployment. We just check it. You can find that for the VLAN 16 and 615, we have already assigned all the interface that connected to AR to it. And besides that, we have already enabled the DHCP functions on these switches, and we create the interface VLAN if 615, and we configure its IP address. Besides that, we enable the DHCP functions on this interface, and we do DHCP static bindings so that all the AI routers can obtain a fixed IP address, just for the management. And what is most important is, besides this interface, we configure the DHCP survey option 148 so that all the AI routers can open IP address from the switches and then open the IP address of the controllers. And you can find that the AI switch, the AI service switch is the gateway of the controllers, and all the AI router, the gateway is still the AI service switches. So by the IP address that opening from the switches, they can communication with the controller. So that is the only config on the AR service switches. And what is other configs about the MPLS network? You will find that for these areas, we will configure the IP address and configure the only protocols we use OSPF. And I have already finished this part. So now I think we can just start our demonstrator. And on the controllers, the first things is we need to log in the controllers, and on the portal page we can find that we have 4 deployment scenarios, and we click the multi-branch interconnection, and you will enter the get page. You can find that the first part is the basic network, and on this basic network, the first thing we need to configure is the global configurations. And for the physical networks, we don't need to do any changes about this page. But for the WAN network, we need to configure its AS numbers and the IP address that's used for the WAN network. So you will find that I have already configured. You can find that I have already configured the AS number of the WAN network, and besides that, I have already configured the IP address pool that we'll use for the controller. I mean, the controller will use this IP address to build the WAN network. For example, for the BGP, we should know that we will have the source address or the connection IP address for the BGP. So the controllers will just random take IP address for the device. And after you finish this part, we will go to the site design. It means we will create the sites for our scenarios. We shall know that we have 3 sites. Its name is branch 1, branch 2, and HQ. And HQ, you should remember that for the HQ, this site we have already created on the previous experiment, but we didn't add the AR3 to it. All right, and you shall know that now we have already power on all the 3 AI routers, and they will get the IP address from the controller. After they get the IP address from the switches, they will try to register to the controllers. So what do we need to do? The things we need to do is we need to get the AR's ES numbers and click the AI device. So we can add the AI routers to the corresponding sites. So for example, for branch 1, branch 2, and HQ, we will add the corresponding AI routers to the corresponding sites. So what is next? The next is we need to deploy the zero config deployment. What is that? It means now all the AR1, AR2, and ZR3 have already get aligned on the controllers, all right? But we need to do other config. You can find that. For example, we need to configure the ZDP. We need to configure the ZDP. So what will configure the ZDP? You can find that. First, we need to configure the ZTP mode, just because I have already finished this page. But for normally, you will find this page, you need to click it and choose the ZTP mode. We have 2 modes for the AI routers. The first mode is the email, and another mode is the DHCP option. And for our scenarios, you should know that all the routers can get IP address from the switcher. So we will use the DHCP option. And then we need to click the link for the different routers. And for example, for the branch 1, we need to configure its 2 links. We shall know that it have internet links and MPLS links. And let's look how to configure the links. For examples, you need to configure the link name, and what is more important, you need to configure the transport network, just because you need to specify this link, which transport or which TN network it belongs to. You can find that it is the internet, and you need to configure the rule and its device and the physical interface. And you can find that we need to configure which WAN, it means which network is an instance, and actually it is the VP instance, and you need to configure which VP instance it belongs to. And you need to configure the protocol that it belongs. You can find that we have the IPOE and the PPOEs. And for the IPOEs, you can choose the DHCP. And then you need to configure the bandwidth of the interface. That is how configure the internet link for the AI routers. And for the MPLS links, most of the things is the same. Just you need to choose the different transport network mode, and you need to click choose the physical number. And for the VP instance, this should belongs to the different VPN instance. And for this interface, we shall know that it have a static IP address, and we have a tables, and on this experiment, you just follow the tables, and you shall know that how to configure it. We have the planning part, and on this part, we have already show you all the parameters that you need to configure this part. So after it, we just configure all the switch, all the switch AI routers, the IP address for the different links. And after it, all the device, after it, and after it, all the device will obtain the IP address just by your config. For example, you shall know that for this interface, for the internet interface, it will be configured, and then for the MPLS link, it will be configured. So now we can log in the device and find that what config have already been configured. For example, for this interface, you will find that normally this interface, it is connected to the MPLS link. So you can find that now this interface is the IP address that have already been configured, and it have already been bound to a VP instance that we configured on the controller's web page. And for this interface that is connected to the switches, you can find that besides its IP address, beside the DHCP mode. Besides that, it have already be bound to a VP instance. And after we configured the two interface, the AI routers, it will try to get online to the controllers just because the configurations about the interface have already been changed. And what is more, the next part is we need to configure the wait a moment, when you configure the WAN underlays, just in the just back to the get page, click the WAN underlays, and then for different the site, we need to configure it WAN routers. So what it means? It means you need to specify the routers for the links. We shall know that every routers have the abilities to go to the internet. So for every link of the AI routers, we need to configure the default routers for it, so that inside the VP instance, they will have the default routers, and by use the default routers, they will have the abilities that communication with the controller. And by use the routers, they will have the ability, they will be able to communication with other AI routers. For example, for the AI router 3, inside this VP instance and inside this VP instance, they will have the router, and you can find that it is default routers. By use the default router, they can communication with other AI routers. All right. So by using these routers, they can communicate with each other, and then we can build our virtual network. So what is next? The next is we all know that when we add the device to the site, we need to specify its mode, and you can find that for the AR3, it is the headquarters routers. We have already specified its rule is gateway and RR. So what it means? This RR, it means it is the RR routers for the virtual network between the sites, and for the border, it is also the RR. But what it means? It means it is the RR routers for the BGP UAP protocols that running inside this site. So they both function the BGP UAP RR, but for different range. All right, the AI router is RR is used for the AI for the AI routers between different sites, but the border is RR is used is inside the campus network. Okay, now let's look at the inter-site networking. So now we know that the virtual network is based on the BGP UAP protocols, and for the BGP UAP protocols, we will need the R routers, and other is the R client. So now we need to click the branch 1 and branch 2 and click the connect menus, and then we can just choose HQs to light we use this command to light the branch establish BGP UAP with RR, and then we need to click the dedicate and then click the OK. So what is the result? The result is the two AR routers, AR1 and AR2, they will use the IP address that assigned by the controller to build the BGP UAP with the AR. Sorry, you can find that. You can find that for the AR3, it have already established the peer relationship between the AR1 and the AR2, and you can find that they are in the same AS numbers, and the IP address is assigned by the controller. All right. What is next? The next is we need to configure the virtual network, and first the virtual network it is the public, and the virtual network public is not used for the between the sites. It is only used for the site HQs, and it is you. And we need to use this virtual network to implement some functions that the AR3 in the VXLAN virtual campus deployment, and it will include this part. For example, it will provide the DHCP address pool and interface for device logging, and we will build the DHCP address pool for the terminal address, and we will configure the source net configurations for device online, and we will configure the net survey for the portal authentications, and we will configure the DHCP service and the email service. So now let's look at how to configure it. The first part is we need to configure the interconnection configurations. We have already configured it, all right? Just we need to create it, and we need to input the name and choice which sites we will have the associations with the VP instance. And you can find that for the virtual network public, and you can find that we only choose the HQ, this site, and after we configure it, okay, and we can click the public. And for the WAN survey, we can find that we need to choose the topology mode is the hub and spoke. And actually, for this VPN virtual network, we don't need to configure this part just because it don't have the requirement to communication with other sites, all right? But I will just demonstrate how to configure this part. And then for the topology mode, we need to configure choice the hub and spoke, and we need to enable the branch-to-branch interconnections. And after we enable it, we will choice which side is the hub side. Now you should know that we need to configure it to execute, and when you enable it, it is the hub for the branch to branch, and then we need to just click OK. And after we finish this part, and then we need to configure the LAN WAN interconnections. You can find that what can we configure in this part. Let's change the config mode from the simple mode to the advanced mode. You can find that in this mode, we can configure the interconnection interface with the borders. All right. For example, you can configure the interconnection interface. Its WLAN ID is 10, and its mode is NTAG, and its physical interface is the gigabit 001. You can click its IP address, and you can click the DHCP option on it, and you can do the static boundings. So you can find that what we are doing. What we are doing the things that we configured on the AI suite manually. Just now we configured it by controllers. And besides that, you can find that we configure what? We configure the WLAN ID. The WLAN ID is the 115th, and it is still the and it is still configured on this physical interface, and its mode is tag and configure. Its IP address configured. So what is that? We configured the network results, all right, that used to communication with the border, and we configured the IP, the interface that used to assign IP address for the device, so all the device can go online, all right? That is what we configured. And besides that, what we need to configure? We need to configure the return routers that to the terminal users. All right, just you should know that this interface is used to communication with the DHCP with the gateway of the terminal users, and the gateway of the terminal users, they will function as the DHCP relay. All right, so for the AI router, they should have the router return to the interface, the terminal's gateway, so that the AR3 has the abilities to return the DHCP packet back to the terminal users. So we can check what is the real configurations on the AR3 routers. For example, for the AR router 3, it configure its VLAN, which VLAN will be tagged and which VLAN will be untagged. And besides that, it creates the VLAN if interface. You can find that. You can find that it creates the VLAN if turn on this interface, and this interface is binding to a VP instance, and you can find its name is 1. And actually, it's on the controller. You can find that on the controller. You can find that for the public virtual network, its WebRF instance, its name is VPN1, and also for the VLAN if 115. It's also bound to this VPN instance, and its IP address have already been configured. That is what we configured for the public virtual network public. And besides that, we need to configure the DHCP pool for the terminal users. You should find that, and we have already configured it. But just remember that now this DHCP pool should be inside the VP instance. So we need to configure the VP instance parameters inside the IP pool, and we have already finished it on the AI router 3. And what is next? The next is we need to configure the virtual network OA and the virtual network RDs. And the virtual network OA is used for the AR1, and the virtual network RD is used for the AR2. And besides that, you should remember that on the HQ, this site, they still have the logical, notice it is a logical network with its name is the OA and RDs. I just use the same name between the virtual network and logic network so that it is easy to memorize. All right. And you can find that we need to click the Wiki network OA and the branch two and the HQ is included in this Wiki network. And for the one service, we need to specify the HQ is the hub site and the branch two is the branch size. And besides that, on the LAN WAN interconnection, you will find that in the advanced mode. For example, now we are in the branch 2, so you can find that for the branch 2, AR router 2 is the gateway for the PC, for the PC5. All right, so we need to configure it. We need to configure. It is the interface, the physical interface that is connected to the PC. It is the NTAG mode, and we need to configure its WLAN ID, and we need to configure its IP address. Besides that, we need to open the DHCP functions so that the PC5 can open IP address from the AR2. All right, and you can now let's try to log in on the PC5. And remember the subnet of this interface. It is this. Remember it. And on the PC5, you can find that when we use the ipconfig command, you can find that its IP address is the same subnet of the AR2. And actually, this IP address is obtained by these routers. And let's log in on the AR2 and find what is the real config that configured configurations that real configured on the AR2. You will find that it creates a WLAN if 200 on the AR2 and enables the DSP functions on the interface and configure its IP address. Besides that, you can find that it configure its physical interface, configure its WLAN mode, and configure if the WLAN is tag or the untag. And you can find that for this interface, its PVID is 200. And besides that, we can check its IP address tables. You can find that for this IP address, this IP address is direct, and you can find that besides that, it received a lot of routers that next hop is the SD1. And what is this routers? This routers is generated by the HQ, which just because this WP instance is still served for the HQ. And you can find that for the HQ this site and for its advanced mode, we configured its WLAN ID, it is target mode, and its physical interface. And so what is that? That is the external network for the logical network in the fabric, all right? And we still need to configure the static routers so that the survey traffic can return to the terminal users, all right? And you can find that on the AR3. You can find that on the AR3, this interface have already been configured, and it is still it belongs to the same WP instance that we configured on the AR2. They are both the VPN2, and it represents the VPN network, and its name is RD that we configured on the controller. And besides it, we can find that we configured so many static routes. And you can find that we configure so many static routers that belongs to the VP instance too. And we should import the static routers on the VP instance on the BGP wheel. You can find that inside the VP instance VPN2, we import the static routers, all right? And we use the route policies to limit which routers can be imported to the VP instance. And all the routers that are configured on the AR3 will be delivered to the AR2. So you can find that the AR2 will have the specific router that designated to the terminal users in the HQ. And what is next? The next is we need to configure the RD, and you should know that for the RD, it is belongs to the HQ side and branch one side. They should belong to the RDs, and for the RD, for the LAN one interconnections, when for the branch one, you can find that we configure its IP address and we enable the DHCP service for it, so we can check the configurations on the PC4. And by using the command of ipconfig, you can find that it obtains the IP address, and the IP address is offered by the AR1, and what is configurations delivered by the controller to AR1. You can find that. You can find that the controller config is the physical interface. And its config is when if 300, and we configure it is bound to a VP instance, and we enable DHCP functions on it. And you can try to check its IP address tables. You'll find that it learns the route that which one is next hop is SD1, and it is delivered by the HQ. And you can find that for the HQ for this site, we need to connect the Wiki network RD with the logic network in the fabric. So we use the interface to connect them together. We configure the physical interface is mode is tagged, and we configure the corresponding VLAN ID, and we configure the return routers that is destined for the RT users in the fabric. And now we have already finished the rich network these configurations. And what is next? The next is we need to configure the site internet access and the fabric configurations. And the first, when you configure the site internet access, when you configure it on the traffic policy in this page. And first, we need to choose the which network we choose the public, and we click the site to internet. And inside this page, you can find that we have two modes to choose. The first mode is the centralized internet access. It means all the traffic that designated to the internet should be traffic by the HQ site. Another mode it is the local internet access. It means the traffic designated to the internet can be forwarded by the egress device of the site by itself. You can find that we shall know that the public is only served for the headquarter itself, so we can just create it and you can find that we need to choose the which interface is used to designated to the internet. You shall know that for the AR3 for the HQ, we need this interface connected to the interface to the internet. All right, and we need to enable the source net. By this config, all the devices that inside this fabric can communication with the controller. All right. And what is next? The next is we need to configure the set to internet for the RD and the OA. And the configuration method is the same. We need to create it, and you need to choose which site need to do the local access to internet, and we choose them, and then we just need to operation it. We need to choose which link is connected to the interface to the internet, and if we need to enable the source net. And for the OA and for the RD, we choose the both device, and we enable the source net on the both side. And what is next? And after we finish this part, all the devices that inside the HQ, I mean, all the devices inside the HQs, they should be able to go online. They should be able to go online to the controllers just because we configure the source net on the AR3 and we configure the default routers, all right? And what is next? The next is we need to configure the net configurations. I don't need to remember we said that before. The controller needed to send a message to the authentication device, I mean the border in the fabric, and it is the proactive, all right? And so it means the AR3 should have the abilities to forward this traffic, but now the AR3 don't have the ability to forward this traffic. And so how to configure it? We need to inside the traffic policy page. We need to click the underlay and click the night, and then we choose HQ, and you can find that we have dynamic net and a static net to choose, and we click the static net, and then we can create static net entries for the AR3, and you need to choose the physical interface, and you need to configure the external IP address. Now we use the interface is IP address, and we need to configure the internal IP address. You will find that it is the IP address of the border, and we need to configure the protocol type. We choose the UDP and configure the external port and the internal port for it, and then now the controller can send the packet, the portal message to the border device proactively. Okay, now what is next? The next is we need to create an interface just to simulate the email survey, all right, and bind it to the WP instance, all right, and I have already finished it on the AR3. And I have already configured it. So what is next? The next is we need to try to do the survey verifies. We need to do the result verifications just to test if all the device inside this fabric do the authentications just like we used it before. Now you can find that, for example, for the PC3, you can find that they can connect it to the SSIDs, and I think it should be able to do the portal authentication normally. Now you can find that the port page can be pushed normally, and we can authentications normally. All right, so now it means our configurations about the AR3 is definitely right. And if you have the time, you can do the connectivity test. I mean, you can test if the PC5 can communication with the HQ. I mean, you can do that. It belongs to the same network. And for the PC5, if they can communication with themselves, all right. And now I think we can check it. For examples, for the now for the PC1 and the PC2, we can try to communication with the PC4 and the PC5. Now you can see the PC1 is able to address this, and for the PC4, I think you can try to ping it. For examples, you can find that they can communication with each other. PC4 can communication with the PC1, and if you notice its TTL values, you can find that this packet they just need two hop, and PC4 can just communication with the PC2. And if you use the trace route, this command, you can find the result about the trace route. The first hope you can find that. You can find that the first hope is gateway. What is the next? The next it is the BGP EVPN address. Okay, it is a logical tunnel address. And what is the next? The next it is the address that we configured on the AR3. And what is next? The next hope is the gateway on the HQ device. All right, on the HQ device, it should be the AG1 or the AG2, and then we reach the PC1. So you can find that the traffic is forward just inside the which network, just because this address you can check it. It should be found on the AR3. Wait a moment and check where is the bit address. You can find that it is the terminal bit address on the AR3, and that is the logical next hop of the traffic. But what is the real next hop of it? It is controlled by the controller, and the controller will just monitor the link qualities, and maybe the controller will steer to the different physical link. And now let's configure the next part. The last part, it is the application identification and intelligent traffic steering. First, we need to enable some features on the controllers. It is on this page. When you configure it on the policy and application management and on the SAC configurations, we need to enable the APR and application identification. We need to enable these two features. And what is next? And then we need to configure it. We need to configure the AI router to report the monitoring data, and we configure it on the. Wait a moment. When you configure it on the monitor settings and the monitor settings on this page, we need to choose the HQ, and we need to choose the AR, and we need to open all the button, and we need to select all the available features. And for the HQ, for the branch 1 and branch 2, we need to do the same things. We need to enable the AR feature to report all the information to the controller, so that by use these informations, the controller can identify the different traffic and can monitor the link qualities, and then to do the traffic steering for the different application. Okay, what is next? The next is we need to let the controller can identify the different traffic. So the first thing is we need to configure the application group, and on the policy and application group, we can create two different application group. The first one you can find that is the FTP, and another one is HTTP. We use the two application group to identify different application. And before it, and actually, we need to configure the. Wait a moment. I think before it, and after it, we need to configure the. Before it, we need to configure the customized application. It means we need to define the config by ourselves. Just to, in this experiment, we use a traffic. We use a software. This software can generate the simulation traffic, and we use this traffic to simulate the server traffic. So you can find that it is not the real server traffic. So to ensure that the controller can properly identify the traffic, we need to do the customized applications. You can find that how do we configure it. Actually, we just configure the traffic. We use the ACL to permit the traffic, and then we bind it to the application group. All right. And then we need to configure the real application group inside the policy application group. We click the FTP, and you can find that inside the SA, we need to choose the FTP, and then inside the custom applications, we need to choose the application name that defined by ourselves, so that the controllers can identify the FTP traffic and FTP traffic, HTTP traffic that we make it by the software. And what is next? The next is we need to do the traffic steering. Just inside the WAN policy and WAN policies, you can find that we have the policy template management, and we need to create the two traffic classifier. You can find that it is the traffic classifier and the traffic policy behavior template. So what is that? And actually, you can just think it is the queues traffic classifier. And by using the FTP, the samples, we can find that inside it is the classifier, and what traffic this classifier will match. You can find that it is the application group that we configured just right now. All right. So you can find that we configure the traffic classifier, and inside the traffic classifier, we will use the application group that configured to match the traffic. And what is next? The next is that we need to do the traffic steering by using the classifier. So now back to the guide page and click the traffic policy, and then click the intelligent traffic steering. So first, we need to configure the traffic steering for the RD for this switch network, and you can find that we have already configured. So just like to see how to configure it, you can find that you need to configure the policy name. We configure the policy name to RD FTP, and we need to configure the which traffic classifier to use, and you need to configure the policy priorities, and you need to identify what is the switch over conditions, and you can find that for the FTP traffic, the switch over conditions, it is like that, all right? And then you need to choose which one is the primary transport network and what is the secondary transport network for it. For example, for the FTP traffic, we choose the internet to function as the primary network, and we use the MPLS to function as the backup transport network. And for the, and then after configured, we need to choose it, and then we need to commit it, and then the traffic steering command will be pushed to device. And for the OA, we need to do the same things, but the traffic is the HTTP. And then now we have already finished this part. And what is next? The next is we need to do the use the command to generate the traffic. And on the PC1, you can find that we use this command. On the PC1, we use this command. You can find that we use this command to wait a moment. We use app3 to listen the port and to just to simulate the service and to simulate the FTP service. And for the PC4, we use the same command just to function as the client. And then we will generate the traffic, all right? You can find that we will generate the traffic. Maybe I need to reboot this process. Okay, now you can find that the traffic have already generated by the software that is running on the PC4, and the traffic is sent from PC4 to the PC1. And we will do the same things on the PC2 and the PC5. And actually, I have already do it. And you can find that we will generate the traffic, and the traffic generated by the PC4, it is to simulate the HTTP traffic, and the traffic that generated by the PC4, it is used to simulate the traffic that is simulate the FTP service. So what is the result? The result is on the controller, you can find that on this page, on the monitor and inside, and you can find that wait a moment, and I need to click the. You can find that now it is from the branch 1 to the HQ. So from the branch 1 to the HQ, you can find that all the traffic is steering to the internet. And if you click the application, you can find that all the application, it is the FTP. And you can find that the application name. And in this page, you can find that all the traffic is forwarded by the internet link. But if you switch it to another VPN which network, you can find that for the HTTP traffic, it is all forwarded by the MPLS link. So that is what we do by the controllers. Okay, all right, now, and I think we can to do the last part. It is to simulate the link failures by manually. For example, now we shall know that from the branch 1 to the branch 1 to the HQ, that all the traffic is forwarded by the internet links, all right? And what will happen if the traffic if the link downs, I mean, between the branch 1 and HQ by using the internet link. So we can check it. Wait a moment. Switch over. Now let's configure the switches, and we will before it we will try to wait a moment on the PC. Wait a moment, it should be the HTTP traffic, all right? It should be the HTTP traffic, and wait a moment, it should be the RD. It should be the FTP traffic, and its primary link is the internet, all right? And FTP, all right? And FTP traffic, and the FTP traffic is generated by the PC4, and then we can try to light the traffic to a longer, for examples, for now you can find that the traffic sent from PC4 to PC1. But what will happen if we from the PC4 to PC1? What happened if we shut down the all if we do queues, we do rate limitations on this interface. We can check it. Now for this interface, you can think it normally you can just think just don't you can just think it don't have the ability to forward any traffic just because we do a queues, and we set the queues value to a very very small values. So you can find that what will happen? You can find that we have some packet loss, all right, and then what happened? The traffic can still forward normally, all right. just because now the controllers have already do the traffic steering to another link. But I think if you wanted to, if you wanted to do the result, you need to wait a moment, just because the controller, the result that is showed on the controllers will be later than the real things happened. It means the controller needed to do the data analyze and data and so the result will not be as soon as possible after you change it on the controller, change it on the device. So maybe just for this traffic, FTP traffic, we can wait a minute and you can see it will be steering to another link. But you need to wait. The traffic should be the FTP definitions, and I think you need to wait now, just because you can find that result is the traffic is steering forward by the internet, and there is no traffic forward by the MS link. So I think you can just wait some minutes. For example, 5 minutes. I don't know. Sometimes 10 minutes you can't see the result. So if you have any questions about this part, if you don't have any questions about this part, we will finish our today's training. Wait a moment, I will check it for you. Wait a moment. No.